Thank you all for being here, also online via the computer. It's a great honor to be at Ideas again and speak here. And boy, didn't we have a great speech from Congresswoman Delbene and then Doug Silverstein on behalf of the FDA, who's doing a great reach out, not only to the American innovators, but worldwide. What a huge gesture. It is really amazing. I have the feeling that the Kolff and Scribner times are coming back. The innovation tempo goes up. Having said that, they knocked me up with this title. And now I'm standing here, but I'm a technologist. I'm not even a medical doctor. I'm not a biologist. So technology, yes, I can tell you a lot about that, but biology is going to be difficult. But I took my crystal ball and I made my makeup and I looked into it and I thought, let's tell about the decade of the kidney. Now, before we look into the future, let's look a little bit back. Now, this photograph is not so much known to many people, but it was a meeting in 1986 in Germany, in Bayern, in Wieringa. And there's two people that stand out there. These are all giants, but two you will know. That is the famous Dutch Seattle connection, Kolff and Scribner, who are responsible together for the chronic dialysis that was possible. And all the other there also, they gathered and they were thinking about how should the future look like. And they wrote it down in a book. In those days, you had real typing machines, so the meeting was 1986, and the book came out in 1988, because it had to be typed. But this book is great, and Murray Sheldon made sure that we got a PDF, so anybody interested, we probably can give you a copy. And in this book, there is a list of 5 goals of the experts, the giants of that time, the fathers of dialysis, saying we have to arrest nephritis, we have to preempt renal allograft rejection, and the utilization of xenografted kidneys. That is something we should pursue. Recycling nitrogen in the gut. Wait a minute, what did we hear today? And the fabrication of a bionic kidney. Those were the goals. Those were not a wish list for Father Christmas. Those were goals that they thought could be done. Now, interestingly enough, the only one that really stood out and grew was, of course, the rejection preemption. There has been a lot of work on that. But all the other points are just now starting up. But it's never too late to start. But how did that come? Well, the innovation programs that were soaring in the US in the beginning of dialysis, they began to wind down in the 1970s, and by 1980 it totally stopped. And that is also a citation from the book itself, a quote. And the book also says, well, they sat together there in Germany and they said, how did it come? Well, the government thought that at that moment that industrial research would be picking it up. But an industrial firm, and we cannot and should not blame any industrial firm for that, but those have the target to lift their shareholders' value. So they invest, but on the shorter term. They cannot invest just for society. They have to invest for the firm, and that's a different point of view. But you cannot blame firms for that. It's how they work. So in 1972, we had this cartoon. We made this cartoon about 1972, in which there was optimism. In 10 years, dialysis will be portable. And the guy there is happy because he thinks, wow, I will be able to move. And look what happened. A lot of innovation. They put a lot of smartness in nearly everything. He even got an LCD screen on his dialysis machine instead of the analog meters, which is great. But the poor guy is still stuck to the wall. Although his smart toilet is so clever that it can detect that the toilet paper is gone and he can send for a drone to bring new one. But unfortunately, the machine is more or less the same. So how can we make dialysis machines more mobile? Or even implantable. And how, and this was also so nicely said today already earlier, how can we make it much smarter than just being a kitchen sieve? Because at this moment, hemodialysis is just a sieve. But we miss the tubulus function, the clever recycler. Well, let's look upon how we stand now. Like said just before, transplantation is at this moment the best available treatment routinely that we have. But it's taking spare parts from somebody else. The good news is you don't need dialysate, but unfortunately you do need immune suppression. The other way that we use a lot, of course, is hemodialysis, in which we have to take the blood out of the body, clean it, put it back, and it costs a lot of dialysate. For PD, well, we leave the blood in the body and we use the membrane which is already there, but we cannot replace that membrane, unfortunately, which is a pity. Now, we spoke, several speakers were there, also about sorbents, but also photocatalytic oxidation. So if we could regenerate the dialysate, we at least would consume less and we would be more mobile. It's a first step. The same thing holds for PD. If we recycle the dialysate and regenerate it, we make it more portable. This stage we are now entering. But we're not happy to stop there, of course. We want to go on. We want to have the bionic kidney, as they said in 1986. So, how about Bill Fazell and Chuvoroy with their great idea of using silicon technology, silicon chip technology, for an implantable hemofilter? This is an interesting step because then, just like with PD, the membrane will be in the body, so the blood doesn't have to leave the body. It stays in there. And instead, you'd only have 2 lines going out for the dialysate. It's an interesting intermediate step towards an implantable artificial kidney. Of course, like Bill Fazell has shown us, this is also a great idea, having the filter and the tubulus. So the tubulus would be the bioreactor with the clever recycling and the active push out of the bad stuff and the active reclaim of the good stuff. That is possible. And on June 15, I had a meeting within the European Parliament, and we were telling them, in principle, this is possible. If we combine the best brains in the world, it could be done. But it depends on how much funding we will get to do it, like Bill Fazell also said. Now, I talked about the immune suppression which is needed for the present transplantation. So such a bioartificial kidney would not need immune suppression because the cells in the bioreactor would be enclosed by a nanoporous membrane which is not transparent for the immune system of our body, which would be very interesting because then people with a heart to transplant by the normal way might be transplanted. So it's a dream, but it's a technologically possible dream. And the amount of funding that we would need would be about 200 kilometers of 4-lane interstate highway. And I'll tell you, when I told the European Parliament, every country in the developed world is easily able to have the money apart to build such a 200 kilometers 4-lane interstate highway, no problem at all. But the trouble is, this is not a highway we want to build, we want an artificial kidney, and we need the best brains in the world. So many countries have the money to do so, if they choose, but they don't have all the brains to do so. So that is the most harder part, combining the best brains in the world. It can be done. The proof is simple. We're here. Bill Fazell was here yesterday. So people seem to be attracted by ideas. So maybe we should expand the ideas formula a little bit more international. Might be a good idea. It has been suggested by a guy named Jonathan Himmelfarb. Okay, and with the immune suppression, let's not forget one lesson that we have learned from COVID. We have seen how much immune suppression does to your defense against microorganisms and your response to vaccination. So it's an important aspect. Of course, Kidney X is there, and it's great. It's a beacon of hope in this world. And anybody who hasn't visited yet, can hardly imagine, but just go there, as I always say. And I said it in Germany at the Dialysis Congress as well. And we see things happening. We see the photocatalytic oxidation, which is constructed here in Seattle. It's a tangible step, and it really works. It needs development, but the science is there. And how do you say that in America? You have this saying, well, it's no rocket science. That means rocket science is, whoa, that's breakthrough science. Let me tell you one thing. I'm an engineer. Rocket science is not science. It's engineering. High-end engineering, but engineering. And that costs maybe a lot of money, but you see the profit from it. These kinds of things need to be developed into products, and the funding for that should become available. As for this project, great idea from the University of California, Los Angeles. Also, a fully technological approach that in principle works, but it should be miniaturized. Now, the good news is, I work in chip technology, and we miniaturize things. Boy, do we miniaturize things, I can tell you. It can be made small, but it will require a lot of engineering effort. Then, of course, the wonderful, wonderful concept from Bill Vassell and Shuval Roy, which is ingenious. And again, it can be done, but it will need a lot of trial and error and so on, like the Apollo program. The first rocket didn't work so properly, but they kept on going. Okay, well, there are, of course, weird guys that do weird science. Let's not talk too much about that. But chip technology plays a role on this, and it can miniaturize a lot of things. And complete monitoring and P-bud removal and so on can be done, complete with a processor and memory. The thing that I'm holding on my fingertip there is 5 by 5 millimeters. It holds all that on one chip. It can be done. Well, we have done that. So what I'm trying to say is, you just had the CHIP Act in America. Well, guess what? In Europe, we also had a CHIPS Act. Oh, that's great. We have both one. And in Europe, we have the Green Deal. You have a Green Deal somewhere here as well, to protect the environment. And of course, a health program. Well, the EU and America both have a health program. And guess what's exactly in the middle? This artificial kidney fits exactly. It's the crossing point of all those three programs. No immune suppression drugs needed. An improved continuity of the therapy and health outcome. You don't have that bang, bang that you have with the discontinuous traditional dialysis. Freedom to move. Well, I heard about freedom to move, and I heard yesterday when I talked about freedom to move, somebody said to me, preach to me, brother. Well, that's it. Freedom to move. No needling. You don't want to have the needling. Well, you can get rid of that with an implantable artificial kidney. It will save a huge amount of water. That's clear. It will save a huge amount of energy. And the transport to and fro the clinic. You get rid of that. And of course, the CHIPS technology can bring you the nanoporous filters that you need. The blood-compatible coatings. Well, if I have to choose one place in the world where blood-compatible coatings are being high-end developed, that's here in Seattle. Thank you, buddy. You make great stuff. And it's happening here. Sensors, well, they can be made very small on chips. Actuators as well. MEMS, they call them, microelectronic mechanical systems. Control units like microprocessors, well, we all know microprocessors are on chips. Wireless charging and telemonitoring, it all can be integrated. So that is one aspect. Now another one is, I'm a technologist, but they also asked me to tell a little bit about the biology. Now I don't know how to start this movie, sorry. So I don't know if anybody there can push a button. It's on the bottom, yes. All right. So this is work done in Utrecht, in the UMC Utrecht in the Netherlands, in which they are combining, they're making a dialysis membrane with biologically active components. So these biological channels will be able to secrete the toxins actively. This is not running yet. It's being done. And there's other universities within this world that also work on that. And again, the message is, if we want to succeed, we have to combine our knowledge. We have to work together and find ways to enlarge our impact. And I come back to the overview that I just showed. I wasn't finished. Of course, I first went into technology because technology is my thing. I'm not a biologist or a medical doctor. But we have seen xenotransplantation has just last year passed a critical moment in which a pig kidney was modified genetically and succeeded in a human. Normally, if you would do that, within an hour it's black and it's dead. And it's succeeded in producing urine. So we're not there yet, but it's a very, very, very big critical step. And it's going to be also a beautiful technology. How soon? We don't know. But we do know that there's now several horses in the race. Same thing happens for the cultivated cell culture kidney. I'm not an expert on that, I'm sorry. But I do know that the next speaker will at least tell you about the xenotransplants and knows a lot about that. So there's different horses in the race, and the good news is it doesn't matter which horse wins. As long as the race will be run and somebody wins, the patients will benefit from that. Okay, so the next speaker will tell about the xenotransplanted pigs. I don't know about that, so let's leave it to the next speaker. I do recommend to you an article, but I'm biased here. There's a conflict of interest because I'm one of the authors. We had a great support from Brazil and from Harvard as well. We had over 1,500 experts from different countries, 100 countries, and asked them, what is your expectation of the future? And we got these results. There's a link. There's going to be a PDF of the slides. There's a link in which you can read the whole article. Everybody was more or less agreeing that probably the best solution would be biology. But also that would be probably the longest lasting effort to do. And in the meantime, we shouldn't sit on our hands. We should work on the implantable artificial kidney and on portable artificial kidneys to just get things going. Your General Patton in World War II, he said, better a good plan today than a perfect plan tomorrow. So let's get going and do this. And we have thus to bundle the best brains in the world. We need to combine patients, doctors and nurses, policymakers, inventors and investors, and engineers, and of course entrepreneurs, to all join in the decade of the kidney, which the American Association of Kidney Patients so dearly constructed and made available to all of us to join. And I can tell you that the European Kidney Patient Federation is supporting the decade of the kidney heartily, and just as the European Kidney Health Alliance are doing, because we see the benefit of working together. And there was an amazing discovery in Europe that from euros, you can, if you put enough in, you can make an artificial kidney. This is a prediction. But another scientific amazing discovery has been made. It even works with other currencies. It's amazing. This is a breakthrough. It's insight that never has been done before. So, ladies and gentlemen, I just say, let's get back to the future and really get going within the decade of the kidney towards an implantable artificial kidney with an international consortium. Thank you so much.